Hello, everyone, and welcome to today's webinar. My name is Melissa Retta, and I'm the Senior Marketing Specialist at Tornatech. We're excited to have you here today. Now, I'd like to introduce to you our presenters, Martin Tomasic, the Director of Sales, and Cole Rigney, the U.S. Regional Sales Manager. Please leave your questions in the Q&A tab and not in the chat. After the presentation is over, we will answer as many questions as we can. Now, let's get started with the presentation. Enjoy.
Well, thank you everyone for attending. Let's get right into the presentation. So what you see on our screen is actually a live demo out of my home office here. And I've taken control of this by the use of Wi-Fi, what we call live view, for strictly a presentation such as this. And so what you see here is an actual electrical schematic of the electrical system of the fire pump controller itself. Looking at the screen here, I'm a big proponent about technology, so you're going to hear me repeat this over and over again, but technology makes our lives easier. And so when you look at a fire pump controller, you're looking at something very unique. The ViZiTouch V2 has been out for about 3.5 years, second generation, about a 7-inch screen. And that's what you see here. Prior to that, we had about a 4.5-inch screen just about 8 years ago. So for people that are tech savvy, who understand this, and any of you, you'll love this. And a lot of this might be a little bit of review for you, but I know you dig into it on your own and have fun too. But for maybe 85 or 90% of our customers who aren't as tech savvy, they might stand away from this and say, well, I don't understand it, but it is very simple. So taking a look at the screen here, here's what we've got. Left side, N1, N2, N3. That's normal power. Immediately, per code, we need to show the voltage. So what we're showing here, 480, 480, 480, as you see, between N1 and N3, which is phase A and C, or from A and B and C, or I should say B and C, we got 40 volts. This is the line voltage right here on the far left side. As we move across to the right, we see a couple of contacts that are in vertical. These are closed contacts, of course. That's basically, the breakers themselves that are the isolation breaker and the magnetic breaker. And as we go from the secondary of magnetic breaker, we have another voltage reading. And really this voltage reading is more for us. It's more for people that are really looking and observing for troubleshooting. And this second reading of 40 volts is taken from the line side of the contactor. So if you were to go further to the right, you'll see a couple of vertical contacts. There's 3 of them. They're open. That is our contactor, designating that it is currently open. So the voltage that we see, the second reading of 480, 480, and 480 per phase is on the line side of the contactor. And what does that prove to us? It shows that we have continuity through both of the circuit breakers. And this is generic across the industry. Sometimes breakers, they'll trip, they won't reset. And so you don't really know whether you have voltage to the line side of the contactor or not. In this particular case, we added it. It's just a troubleshooting benefit for anyone who's really looking at it. We can look at it and immediately come up with the reason as to whether or not you have voltage or not. It just eliminates that part of the controller. To the right of the second voltage grouping, we have circles with 0A. These are amps, ammeters. So as the motor itself, which is shown here on the far right side with the M in the circle that's in gray, being unenergized, that when the motor is energized and running, it will be monitoring the amperage of each phase of that 3-phase motor, as is the voltage. These are all required by code. We do it with color graphics touchscreen. It's quite nice. So looking at this immediately, you see, and it's like driving in the United States or anywhere in the world. In most cases, if you have a stoplight, you have green is on or go, energized, yellow is caution or transition, and red is stop or off. Same thing applies here. So again, looking at the specific diagram, you see we have power all the way through to the line side of the contactor. Contactor's open, the motor is gray, it's off. Now below this is quite nice because what we're showing here If we did have an automatic transfer switch added into this with a genset, this is what you would see below it. You see A1, 2, and 3, alternate power, phase 1, 2, 3. In this particular case, the genset itself is not running because we have red being off or stop, 0 volts in each of the boxes across the phases. And again, as you go to the right side of that, you see contactors that are open. And all this really, again, we could not have both of these energized and have both sets of contacts closed because obviously it would be a direct short. We can't do that. So the arrow in the middle here is pointing upward. And that is saying, hey, we're powering from the normal power. We'll show you as we progress through this that as we do a test for the genset, this will reverse and go point to the bottom, and we'll just do a switch. So it is possible when you're doing checking this, that if you do have a generator running, that you'll see voltage. You'll see green and voltage is reading in these boxes, but you can have the normal side and the genset running at the same time because only one will be connected in linkage to the motor itself. So again, if this did not have a generator, then the bottom part here wouldn't be here. It would just be the top part that's green. As we progress from our what we call the home page, as you see in the top center there, we see to the bottom right side some pressure readings. And I'm going to click on this just to enlarge it a little bit. So again, the red again would be cut off. So right now we currently have a 90 psi turn on pressure, the cut in. And in this particular case, the cutout is 100 psi. And the system pressure here in the blue circle in the middle is 111 psi for the system itself. As I progress, and I'm going to play with this on my desk with the demo, I'm going to increase the psi pressure. As you see, it's jumping up to 146, dropping down to 143, and so forth. As long as we stay above that cutout, which is 100 psi, the system will remain off. Now, before I show the activation of this, I want to go through a few more things. On the bottom left side, it says automatic controller. In the middle bottom, pressure actuated. Bottom right, manual shutdown. All these items I'm talking about, what type of controller is it? Is it pressure actuated? Is it in manual shutdown? The cut-in pressure of 90 psi, the cutout at 100, the system pressure 116, an ammeter, voltmeter. These are all required by code. We like color graphics. You can look at one screen and look at the complete system and what's going on with that system. Is it operating? Is it not? Is it emergency power? Is it not? The system pressures, and you get a read. You know, and technology has really improved. A lot of the other manufacturers in the industry have followed suit with color screens also. Maybe not as interactive, but I think it's great because technology has moved forward in our industry. We're very conservative when it comes to life safety, so moving forward, it's slow and methodical. Let's look at the top right side. We have a date stamp, the date, time, and year. It's a little off, I see at this point, but again, to the right of this, 73 degrees Fahrenheit. What's quite nice about this is that if I click on this, we have the option of going into centigrade or Fahrenheit. And most everyone offers this as an option. Pump room temperature monitoring is standard for us, but it is available from anyone else too. And again, this is just a benefit for you. Predominantly when you get into situations where you do have something freeze, you get a sensing line freezes, it happens overnight. Things happen, people blame the controller all the time, and then we find out, well, no, it dropped down to like 17 degrees Fahrenheit, and that's why we froze and the pressure transducer went bad. But by morning, maybe it's thawed out or something, but it causes problems. So having a pump room temperature really helps minimize that. It gives us more data, and that, again, is a standard feature. It's actually built into the fascia of the V2 housing itself in the front. To the right of that, we've added the battery. And so what you see here, obviously, is a full charged battery. Again, if it was a quarter, half, 3/4, you would know that based on what you see. So looking at the screen, again, most everything here is required by code. It's one visual look at this screen to see exactly what's going on with the system. Typically, everyone is shipped with manual shutdown. That's required by code. If you change it to an automatic shutdown, and we'll get into that in the near future here, you need the AHJ's approval to do that. Again, the unit itself is pretty self-explanatory. So what I'm going to do here is do a system pressure drop. Watch the PSI on the bottom right side. It's visual. Take a look at the screen. Top right, we see it's a Y, delta. So for the techie people, literally, we have the icons for each of the types of controllers that are available, whether it's a Y delta, across the line delta itself, a solid state, soft start, or you can even do an auto transformer. Any of these, the icon would pop up in that top right side for people that want to know, and it'll tell you what type of controller you actually have. So I'm going to stop. I'm going to press the stop button one more time. I want you to see this. The pump on demand is there because we're below 90 PSI cut in. We're at 69. So hence, the signal to start the motor happens. Pump on demand and auto. It tells you why it started. Again, the green ring around the motor designates that it's energized or on. As you see, the contactors are closed. You see the ammeter. We're talking 81 amps across each phase, which is fine. It's normal. You can visually see that. And obviously, if you had one that said 81, 42, and 84, you know you have a problem with your B phase there, and it could be an internal short to the motor itself. Degradation of the motor over a period of years or insulation, things like this happen. But it's visual, and it's quite nice to look at this. So when you have a pump on demand auto, there's only a couple reasons why that actually is going to happen. Obviously, I think one of the main reasons is a lot of times the jockey pump controller or pressure maintenance pump, it's tripped offline. So it's not maintaining the pressure, and the main controller turns on as normal leakage occurs. So either it's tripped offline or it's off. It does happen. People turn it off, forgot to turn it back on, and the system kind of slowly works its way down, and the main controller turns on. Number two, well, you have a main break. Something could be a tow motor runs into one of the pipes somehow accidentally, causing a main leak in the fire system, and it could be many different things. Another reason, we've actually had people that open up valves that shouldn't be opening up valves, thinking that they could just tap off water for a variety of different things, making concrete, washing trucks, having the ability to reduce the size of that valve and spray things down with a hose. There's just so many of them. I'm sure you could add to the list too. So again, there's really only a couple things. And the last major thing is your system pressure dropped because you got sprinkler heads open and you have a fire. So it's got to be one of those. But this is really the only time you'll ever see pump on demand auto. So let me bump this back up. As the system pressure increases back up across 100 PSI, which is the cutout, you see the pump on demand's gone, but it continues to run because we have a manual shutdown. And that's required by code, as I mentioned. I'll reiterate that again. If you go automatic shutdown, which is acceptable, and all manufacturers have that, you need the AHJ, whether it's the fire marshal, the local electrical inspector, of that. It could be an FM guy, whoever, they need to sign off on it. It's good to have that in writing. So let me manually turn this off with the button on my demo. Now I'm going to do a start here. Oh, okay, and here's one other point I want to show you. We ran this for 3 minutes and 2 seconds. So it will keep a running record, and this is quite nice because when you're flowing water and you're doing a startup test, you know, half the battle is knowing how long you've run the pump. And military like to run it a little bit longer than what you normally would for a commercial building or, you know, a distribution center, what have you. But that is an easy way of tracking how long it actually has operated. Then you can shut it down, let it cool down a little bit. So what I'm going to do is press this and you tell me how it started.
Manual, Martin. I'll answer it for you.
Yes. Again, it's not manual started this. Manual means someone physically had to go in that room and press that green start button on the face of the controller itself. And that is a dead giveaway. We get calls from time to time where people say, hey, the pump starts by itself, and we'll have one of our authorized service providers go out to the field, and they see this and they go, all right, let me look at the data. And they'll call the gentleman over and say, let me show this to you. This is not starting by itself. It's manually started. It's telling us how it started, obviously. Someone has to come in that room, press that green start button for this to be in a manual mode. Again, if I stop it and start again, manual mode. Now, if it was a deluge, it would say deluge start. If it was emergency, EMERG, it would show you that it was an emergency start with the emergency start handle. So this is the part I'm telling you, for people that are not as tech savvy, all the data will be put on the front screen and tell you what alarms, how it started, what issues you might have. It's going to be right there for you. You might not even have to get in the data to do this. So let me just do one more thing here. Let me do I'm going to do a regular test of the generator. Now, again, when we do NFPA 25, typically by code, diesels should be tested once a week for 30 minutes. Electrics typically are once a month for 10. And depending on the type of location, the cities and so forth, and really the density, you know, you might end up doing this weekly with electrics. But I'm going to do a test here and do a transfer switch test. So as you can see, we send a signal to the genset. It's ramping up, yellow's caution, it's still trying to retain it. And when the generator, before it switches over, I mean, it needs to get up to 90% of nominal voltage, needs to be in sync at 60 hertz, and there must not be a phase reversal on the emergency power, otherwise it won't transfer over. In this case, it was successful. We have it energized. You see the arrow now points down, and we now, should we have a pump on demand, it will be running off emergency power. And the way this is set up, we run this for 5 minutes. This is adjustable timer here, but typically we have it factory set so that if normal power is maintained for a minimum of 5 minutes, it's showing stability. And part of this, again, before you transfer over, so I'm doing a regular test here, a manual test. But in real life, if the whatever may drop, if the voltage drops for a fraction of a second, there is a delay, a 1 to 3 second delay required by code that's adjustable before a signal will be sent out to the generator to start off. And why did they do that? They don't want to have consistent voltage fluctuations that's going to cause nuisance starting on that genset. So that's why that delay's there, and it is field adjustable. Typically 1 to 3 seconds is what it's set up for. And then on the flip side again, before it transfers over, there's a slight delay once it meets that criteria, as I mentioned to you. So again, it's timing out. In this particular case, it knows it's a test. As long as we have stability for 5 minutes on the normal side, it will retransfer back and let the genset either cool down for a period of time, whatever the timer might be on the genset itself. I think on our screen, it'll only run 5 minutes. And once that expires, it will cut the signal off. And then if there's a timer that overrides on the genset, it might run another 25 minutes or whatever that might be. So what I'm going to do is I'm going to retransfer here.
Hey, Marty, we probably should make note of the fact that that button is for testing only. It's not used for flow testing. Like if you're running your pump at the time and you're trying to do that, transfer over to the alternate power while it's flowing, that button is not to be used for that. It actually won't do anything. If you push the button during flow, it will not start the generator. So the way to do that is to kill power.
Exactly. That's a very good point. The true way, as Cole mentioned, is kill power. You can kill power on the flange-mounted on-off switch on the normal side, or people just cut it off at the pole, or the pad mount, or the volt transformer from the utility will do it. But that is the best way to do it. When you're flowing at 150%, you need to make a transfer. That button is not designed to be under load at all. The pump is not going to run. It's just really for your testing to meet NFPA 25 requirements. So again, here we are. We're back on normal power, arrows up, and now we're just counting down 5 minutes. So I could stop the gen set right now, and we're back to normal. So that particular test will be recorded in the data as a genset test, which is quite nice. So let's go a little further here. Where else do I want to look? Let's see what we need to do. I will drop down this menu to give you an idea. Home obviously brings you to this home page all the time. The bell will bring you to the alarms. Any occurred or active alarms will be listed in this category here. In this particular case, we put some prior to this, so we had some occurred alarms, and we can hit the reset button here and clear it, and any alarm that is listed in there will not go away until you hit reset. And then once you clear it, it goes into the data. It's collected for data in a almost like a spreadsheet format. So that really, it just doesn't go away. It definitely will keep track of all this. Now, one thing, if you do have an active alarm here, you can't reset it because it is active. It won't let you do that. The gears, basically, this is where we're going to make adjustments. So on the bottom left side, there's a padlock. And again, many people have known this for 8 years. We have a code, a passcode. We don't want anyone touching this controller, making adjustments to the parameters unless they really are authorized and knowing what they're doing. It's the right thing to do. It's life safety. We're all involved in a loop. We want to make sure it functions properly to save lives if and when it needs to be used. So let me just add my demo passcode in there, and you see everything unlocks. How simple is this? All right, well, depending on what part of the world you're in, we could go from PSI, KPA, bar, MH20. Typically, the two I see is PSI and KPA. It's just a simple click of the button. But obviously in the US, it's PSI. Maximum 300 PSI. Well, the pressure transducer is actually rated higher than that. The pressure block is rated up to 500 PSI. But if you want to change this to widen your scale. For example, let me put you back at home here. This scale is from 0 to 300 PSI. But I have very quite a lower pressure here. If I'm not going to exceed over 100 PSI or 119, I might want to squeeze that down to 200 PSI, and I'll show you what it does to the system. If I were to just change this to 200 and go back to home, it spreads this open a little bit wider, 0 to 200 PSI. It's a lot easier to visually see it when you look at it, whether it's in the enlarged version or on the screen itself. Just a little thing I wanted to point out because I do get questions on that. All right, let's get right into it. The cut-in. Well, I want to change the cut-in. I really want to have it set at 85. And honestly, I'll leave the cut-in at 100, or the cut-out at 100. So I'll go back to home. You see just a simple couple keystrokes. My turn on pressure is 85 PSI. My turn off is 100. I play this adjustment here on my demo, and again, 69 drops below. We have a pump on demand. I need to manually shut this down. One little feature here is we have the option of automatically putting it 10 PSI. So if you want to do one less keystroke, whatever your cut-in pressure is set at, in this case, I'll lower it to 80. You see, it automatically puts the cutout at 10 PSI more. On a manual shutdown, it doesn't matter really if the cutout is 1 PSI, 5 PSI, 10 PSI above the cut-in, because it manually has to be shut down. The only time it really is critical is when you have an automatic shutdown. You want to make sure, number one, that the system pressure actually can be met. So if you don't want to do it and you want to manually do it, just check the box and you can do whatever you want. And here's something that I found a few people have done. I had someone who actually put the cutout pressure very high up. So even though the cut-in, I'm going to show this to you, the cut-in was at 80, and we have a pump on demand, and the system pressure came up and came up and came up, and all of a sudden, the system pressure couldn't deliver any more than roughly 175 or 176 PSI. The gentleman, I asked it, he goes, "Oh no, we just shut it off with the flange-mounted on-off switch." I go, "Well, I have a simpler thing to do here," because even when you manually shut this off, you have to have the system pressure above that cutout point. Cole?
Yep, I agree.
I thought you were going to mention something there. So,
oh no.
So anyway, that is a given, and it's very difficult because it's just minor corrections. I think everyone really knows that. Let's just do 110 there. So typically, again, you'll see that adjustment there. Now we can do some periodic times. I mean, the code requires us to be able to have an automatic periodic test. Again, this is to meet NFPA 25 requirements. I can click this little box here. I can pick a Monday. I can pick it to be, start on at 7 a.m. I should clear that. And this is actually, the duration is going to be 10 minutes. And really all I'm going to do, it's going to be a weekly test on a particular day here. Let me just look at this real quick.
That first one, Marty, that's the hour, and then the second one is the minutes.
Correct. So right now I've got it set for 7 a.m. in the morning, or I'm sorry, 7:10.
Yeah.
Obviously. I think we just keep it. So it's 7 a.m. in the morning, and the duration will run 10 minutes. So every Monday of every week at 7 a.m. in the morning, you're going to have a weekly test. It's going to turn the unit on. It's going to run for 10 minutes. It's going to shut down. It's going to record it as a test. The one thing I've seen this happen in one area in the Northeast, the gentleman would grab his cup of coffee. He says, "This is great." I go walk through the door and I sit there and I drink my coffee and watch this run. But over a period of weeks or months or whatever time, and it's going to automatically do this every week or we can adjust this. We can go test every other week or once a month too. So there's adjustments there, whatever you want to do. The problem is what if the person says, "Okay, I got to get the phone," so he walks out, and pretty soon you stop sitting there and watching this run for 10 minutes. I don't like this, doing it automatically, because code wants you to be there when the unit is running. They want you to be in front of that system. So I know it's required, but I don't really see a lot of people using it. But I just wanted to point it out that it's something that's standard in all manufacturers of fire pump controllers.
Yeah, that's a requirement. But then if you're in the room, might as well just push the button anyway.
Yeah.
Instead of setting it up automatically.
Agreed. So again, the run test we show is 10 minutes. You could change that if you want. Date and time, let's get into that. So we're showing today's date. We're showing the time. What is the time here? We got 11. Okay, so updated the time, but any logs, this is something that they'll do a commissioning, is update the time also, because any logs that are documented in the memory will lock into that date stamp. And if it's incorrect, then that's exactly what you're going to see in the data that you're going to be viewing. So I just corrected this to 11:48, and again, this is exactly what we're going to see. Advanced, let's just do a few things. Again, we need to do let me back up, a normal phase reversal. Sometimes that's required. I have a test going on right now, so again, I'll back it up. Normal phase reversal, I'll start the test, and I'll show you what it looks like here. You see it's auto, normal power phase reversal, it's a test. I go to alarms, it shows we have a test. I'll go back in. Another thing we can do here is we can actually get into the alarms, like I mentioned, and pick any of these alarms. If we want to do a motor trouble, a pump room alarm, phase loss, we can actually do tests right here. If they're connected remotely to the annunciation panel, we can do tests right now on any of these alarms, as long as they're connected directly to that annunciation panel. Loss of power, obviously, start a test there. We can scroll down. Low ambient temperature, we can do a test there. And again, here's the home, low ambient temperature shown here. So the alarms, yellow is critical, yellow is secondary, and again, that's what you're looking at. Normally, if you have a phase loss, well, you lost a power, it's going to be red, and then you'll have a variation of like, I'll say phase variation, voltage variation, that'll be yellow. And really what happens here is that you really want to focus on ones that are red, but the alarms, there's like 18, 19 alarms, and they will ultimately all show up on the screen if necessary. Let me just get back here. All right, let's move into outputs. So TB1 through 6 are our remote alarm contacts. Again, those contacts are rated for 8 amps at 240 volts. And TB1, again, it's motor run, it's fixed, it's required by code. TB2 shows loss of power, phase loss, L123. It's locked, we can't touch this, it's required by code. 3, normal power phase reversal. Obviously, those 3 are the key. Motor run, phase reversal, and loss of power.
Yep.
Now, TB4, pump room alarm. I've covered that before. There's probably 4 or 5 different alarms that fall under that. TB5, motor trouble. About 3 or 4 alarms fall under that. And TB6 is a freebie. Unless it's a soft start, a GPS, this one won't be free, won't be available. But what you're able to do with TB4 or 5 is you can reprogram this if you want. For the sake of doing this, let me go to TB6. You could sit there and change this, and I can call it coal. Well, I'm going to type this in. I can type in coal. So this contact's going to be called coal, and it's an alarm. And so what we're doing here, you see on the left side, it's an open alarm. And let's just do something here. We're going to make it a over voltage condition, which typically is pushing close to 15%. So if we have a dedicated alarm, or maybe you need another motor run alarm, you know, it doesn't matter, but you can isolate a specific one in the field if you need one. And so this particular case, okay, it's an overvoltage, it's dedicated. If we run across an overvoltage condition, it will close this particular contact when it senses that. Now, what if I want to change that from an open to a close? Well, all I have to do is click on it. And now what will happen is an under voltage condition, the contact will open. So let's look at this. We could also add another one here. We can add alarm here. And instead of, in addition to over voltage, I can go, well, let's take a look at phase unbalance. So if I have an over voltage or a phase unbalance, that contact will close. We can also change the status of this. Instead of or, one or the other, I can go and. So in order for the contact to close, I need both of them to be activated. So I need over voltage condition and a phase unbalance to occur simultaneously for that contact to close. Makes sense. Just wanted to show that to you.
There's also one thing to know. We can we're not limited to just those 6 alarms. If you want 25 alarms, we can do that. There's always expansion boards if somebody has needs for, well, there you go, the expansion cards for more alarms.
8 expansion cards, I think, what, 8 to 10 contacts per board?
Yeah, we can add a lot.
It's pretty easy. What we'll do is we'll install it. It's really a daisy chain from the existing IO board and a click on expansion 1 to turn it on.
Right.
Pretty easy stuff, but we'll normally send an update if it's done in the field. It's a good point. It's a good point. So again, our remote alarm contacts are 2 open and 2 closed. So that's quite nice, because if you have to, especially with diesel and things, if you're running, you know, an engine run and you have like maybe an alarm or a light, a strobe, you can do that too.
Right.
And a lot of cities call for not only a local, but they want the, I'll say, alarm panel in the lobby, but they also have one that's further out, so they need 2 contacts. I think LA, Denver, maybe even Portland, if I remember. Is there anything else you could see here, Cole, that we need to cover?
I think we talked about looking at the factory settings just so people can see the current.
Good idea. So let me go back to home. The reason I'm going to show this to you is because if you ever have to do a software update, drop down the menu, click on the gear, make sure that you're unlocked, go into advanced, factory settings, top line, under program, it shows you the current version of the program. So I take a picture of that on 2.5.3.2. And if I needed to actually upgrade my program, all I do is I have it loaded on a dedicated USB. I open up the access to the externally front-mounted USB port. I insert that, and I click Update Program right here. And of course, I don't have one in there, so there's nothing to update, but that's as simple as it does. It tells you when it's been completed, and then when you're done, you want to go back to factory settings once it reboots to make sure maybe it's 2.5.3.3 now. Again, I didn't do any updates, but that's where you would find that. It's pretty simple. Okay, back to the home. Let me stop this controller real quick. Look at data, events. Events. This is going to really cover pretty much every event that it sees. So I'll do a manual start, manual stop, manual start. Anything that happens to this controller, it will document it.
Yeah. Including all those tests that you had just done too, when you're scrolling through the event log. Everything that happens goes in there.
It does. There's a test right here. Well, loss of power test, temperature, low ambient test. These are alarm tests I did.
Yeah.
Motor started in automatic. Alarms reset. Generator stopped. It goes through everything in detail, and then some for us. What's nice about this is, again, we have what's called save logs, and so for whatever time frame this unit is been in service, we will have a month full of logs for each month of every year this has been in service. So if I drop down, let's drop down to August of 2019. And in this particular case, I only have 2 days that were a lot of activity on logs. This is my demo. That shows you I only used it twice that month. But again, I can scroll down the logs. If you want to get more techie, I could funnel it. I want to see discharge pressure. I want to see when the motor and the jockey ran. You see the 3 I picked. I go back and it funnels out of like 17, 18 alarms. I pick 3, and I can monitor this quite easily on the screen, and we're talking August 6th of 2019. That's what Save Logs does for you. You can look at the historical data right here without having to download it and put it in a laptop or desktop at your office to look at what's occurred last month, 2 months, a year, 2, 3, 4 years ago. It's really an advantage for troubleshooting. Pressure curves. Pressure curves, these are live. These are actual pressure curves. As you can see, I'm looking at 1 day here. So look at what we have here: cut in, cut out. Discharge is green. Jockey is red on the is green on the bottom, and the motor running on the horizontal plane is red. So in this particular case, that's a day. I'm going to spread these out 12 hours. And the reason I'm doing that is because we're drilling down 5 hours, 3 hours, 2 hours. It spreads it out much easier to see. 1 hour, 20 minutes. We can go 5 minutes. It's just something we can look at. And at the same time, if I were to show this to you, there we go. Trying to get to the very end. There we go. Now I want to jump to 20 minutes. And I'm doing this for a reason. I'm going to go down to 5 minutes. So watch what happens when the pressure drops. You see, we're seeing actual pressure increase, actual pressure decrease, live curves. You see the motor.
The motor has come on down there at the bottom now.
Correct. I'm going to stop it. Now, for people that aren't so tech savvy, you can go to the bottom left side and convert it to a spreadsheet. And so here's your date stamp and time. Here's your cut in, 80 PSI. Your cut out was 110. Your system pressure was at 141. Anytime 17 has a 1 under it, it shows that the motor's running. Anytime 18 has a 1 under it, it shows the jockey pump is actually operating. So again, if this makes life much simple for technology, makes your life easier, you can convert it from actual curves to a spreadsheet that's downloadable. Power curve, same way. In this particular case, I'm going to bump this up for viewing real quick. And I'm going to drill it down a little bit more. There we go. So what we have is motor running here on the bottom horizontal and increases in current. That's what we're seeing here. Motor starts. If I were to convert this to a spreadsheet, again, what we see is date stamp. Here's your voltage, A, B, C. Current, A, B, C. And we have current because under 17, the pump's been running. 19 will show me whether I'm on alternate power or not. And this is really good data because if there's a problem where the motor is drawing excessive current on one of 3 phases, it will highlight it here. This has happened before. We had a motor single phase. It drew 10 times, 12 times the current it was supposed to on 1 phase only. And its single phase shorted out and it damaged the controller and burned the motor up. Well, this data proved, number one, is that when this occurred on C phase, the voltage from the utility dropped from 480 down to the low 300 volt range, 312. Because the current went up, the voltage went down. But we never single phased from the utility. And we tracked this until it burned out. It was something that actually shorted out internally in the motor. And this spreadsheet proved that. So data is really good for troubleshooting. It's exceptional amount of information you have. Pump curves, we can actually do manual pump curves. I won't get into too much of this, but we can do automatic with a digital flow meter that's available in the market now that sends us a 4 to 20 milliamp signal or 0 to 10 volt. We can do that. Statistics, all-time statistics. This is actually when it was commissioned and how much time we have on this, obviously. First statistics. Okay, here we go. This is cumulative. So I started it on this, last time I started it was from this date, and here's the amount of time I have. The motor's been started, it got 29 hours, 58 minutes, 160 starts. Last time I started it was today at this time. It ran for 9 seconds. My highest and lowest pressure will actually track this. I'm sorry, TSA, I think they broke the pressure switch, and I plugged it in and didn't realize it was broken, and it went up to 9,694 PSI. So that was the max it saw. Average was 127. Temperature here, again, pump room temperature, 32 degrees was minimum, freezing. 74.3 was the max. It's good to know. Jockey pump, again, we do this by pressure. You have pressure starts dropping, and all of a sudden, as time goes through, the pressure comes back up above cutout. There's only one thing that's really going to cause that to happen is the jockey pump's going to operate, brings the system pressure back up rather than continue to drop and turn the main controller on. And we do that with algorithms in the software. And the same thing with the generator. We got the number of counts, the amount of time on a gen set. Last time it started, ran for 3 minutes and 42 seconds, which was today. Last service, we can actually set this up to do time frames of and I'll show this to you in the next drop down menu right here. We can actually do this, and I talked about service done. Oops, sorry. Let's go back in here. I need to have that unlocked, I'm pretty sure. Let me just unlock that. That's why it went back. I keep hitting the wrong button, my fault. So service. So what I could do is service intervals here. Last service date was this date, which I clicked. I can literally set it up for 6, 12, 18, 24, 36 months. And if I set this up for, say, a year, and I hit service done, I go back to the screen I keep doing that. In 1 year from today, I will have a yellow alarm coming across the bottom of the screen that says service required. So it's a good way to track if you have specific requirements that you need to do, you can have it set up that way. It's quite nice. One other area. If you don't set the jockey pump cut in, cut out when you're doing commissioning, you can always go to this screen, unlock it, and you can adjust the jockey from here. You can change it to whatever you need to do. It's quite easy. Another thing here is if a Tornatech reference card here, if you want your own card itself, you can forward your business card to us, contact information. We'll create a JPEG that we'll send to you, and you could stick it on a USB, insert it into the front accessible USB port, and then go to this screen and just click on that right there. It says update from USB, and it'll put your card there.
One note on that jockey cut in, cut out, that doesn't actually control the jockey pump. That's just for statistic purposes, so that we can keep track of the jockey's start and stops, but it does not actually control the jockey pump.
Correct. There's really nothing under I guess, if we look at question mark, we show include a manual, but what we want to do is, in this particular case, if we wanted to do a download, and I can show this to you real quick, I'll insert my USB into the port here. It's reading it right now. Should pop up pretty quick. All right, so here's my USB. I'm going to do a full download of all the history and the data, and I'm going to include the manual. Manual probably could be 60 pages, but it's got as-built drawings in there, and I can click download. So we're complete. I can remove that. Really what I want to do is show you this. So what I've done is all the event logs, all the statistics are in like a text file. The pressure curves, if there's power curves, or pressure curves, power curves, if there's logs of pump curves, they're going to be in a spreadsheet, but not curves, they'll be data. And you can, that's what we have here on this USB. You can input it, give it to your customer. You can do this on a routine basis, but this covers everything from day one, which is quite nice. And the last thing we do about 22 different languages on the electric. So we're English now. If I switch to Italian, you see everything is in Italian here. If any of this occurs, any events occur during this time, it will be documented in the data as Italian, not English. So if you download this and you've got a dozen, events that occurred, it's going to be listed in Italian. Unless you go back and switch it back to English, then you'll be good. So Cole, is there anything else we need to review real quick?
I think that covers it for the electric. I think pretty sure we've covered every topic on that one.
Okay, so what I'm going to do here, because we spent more time on the electric, because the back door of the electric here underneath is pretty much identical for the diesel. So what we're going to do is we're going to move off to the diesel. So I'm going to bounce back off and get reconnected here shortly. Bear with me.
No problem. Oh, you got this one on the startup screen.
Yeah, we could go through that real quick. Or I can just get this unlocked if you want me to do this.
Yeah, I guess we go ahead and run through it. It doesn't take that long.
Nope. Okay.
We can just go ahead and start it. So that's the startup screen. Whenever a control panel, before it's being commissioned, this is the screen that you would see. So the first thing is to check the power, which with the diesel is just 120 volt coming in. That's basically just to feed the chargers, that is then feeding the battery. So you can see right there that we've got amperage going to the batteries, and the batteries are already at their 13.8 volts. So everything is good and healthy there. So you can see that it's already got the check mark saying that it's good to continue on the startup. If the batteries were not charged yet, you would have red X on that one. So then the next one is the engine startup. It's where it's going to want you to put it into hand mode so that you can manually crank the engine for the first time.
Yes. Doing that right now.
So from here, we're going to want to manually crank it. It's going to have to go through checking all of the continuity of the wires that are connected from the engine to the control panel. So that's what it's going to be doing for the next 1 minute and 2 seconds is engine alarm validation. You can skip that, but it's best to let it go ahead and do that. That way you can, verify that everything has been connected properly. For the demo, there is actually nothing connected, so we could skip this one if you wanted to. Do you want to go ahead and skip it, Marty?
Yep, I think so.
Yeah, just to move ahead. We should get the green check mark. It doesn't work if you do that. Darn it.
I'll just skip the whole one.
Yeah, that works.
Pressure.
Yeah, set the pressure. This is where you'll set your cut in. And like Marty said, on the electric, you have the option to where it just will, if you enter your cut in point, it'll automatically populate the cutout 10 PSI higher. If you want to modify that, you can check that box and change it. It also gives you the opportunity to go ahead and put your jockey pump cut in and cut out as well. And again, that's not controlling the jockey, just for not diagnostic purposes, but for statistical purposes. It's not required.
So again, everything that you saw on the electric is pretty much the same on the diesel. As far as the layout, if I go back to the first start, any configuration here, auto shutdown, we really didn't cover auto shutdown because not very many people do it. There are some. Talk about periodic test, run test, we covered that. And then we hit service done. And so the most important thing, obviously, is we want to make sure, if I look at the pressure, is the pressure above the cutout? It is 120 and 121, because if we hit service done and we're below the cut in, it will try to start. Up until that point, it's been totally locked out. And I do have this running because I never stopped it from the engine run.
From the validation point. Yep.
Yeah, exactly.
So this is the home screen of the diesel. Like you saw with the electric, it is a very similar design, very similar setup. Green is still good and red is still bad. But now we have some different icons. So you can see on the top left, we're going to have the two chargers. That's the two lightning bolts there. That's signifying that we have power coming in. Everything is good. To the chargers, they're sending a 1.1 amp trickle charge to the batteries. So we've got two different modes for the battery chargers, either going to be a bulk or it's going to be a trickle charge, like a float. So floating and the trickle charge is where you want it to stay the majority of the time. If it's going to be a bulk charge, it's going to be burning out the charger. Yeah,
I mean, float charge could be anything, even up to half 500 milliamp, half an amp. Bulk could be up to 10 amps. Right, what batteries are needing, and that's code requirement. The chargers need to be rated for 10 amps anyway. So
right, yeah, it's just if it's stuck in that mode constantly, then it's most likely you have something wrong with the batteries. But it's just something to pay attention to. But it will be on the screen, this being the home screen, so you can see if it's in bulk mode constantly. And then you have the two battery icons, so it's showing that the voltage is healthy. That's why everything is green. So continuing on to the right, you have the same parallel lines right there, showing that those contacts are open. Those are signifying that's the start contacts for the motor. And then you've got the gear, which is the starter itself. So it's going to show when we're trying to start, because when you're trying to start the engine, it's going to give it 6 tries in an automatic start. So you're going to pull from one battery bank, and you'll see the contacts close at the top for that one. And then if it's not successful on the first try there, it'll switch over to the second battery bank, and you'll see the contacts closing down on the bottom. So it'll try 3 times from each side before it eventually gives you a fail to start. But that's what those two lines signify. It just shows you visually on the screen which battery bank it's pulling the power from. You actually can do, if you push for a manual start, if you push the numbers 1 and 2 at the same time, it'll pull in the power from both batteries at the same time. That's in an emergency kind of need. If your batteries are drained, you can pull power from both and hopefully get the engine started with that. Then you'll see the next big icon there. That's the engine. That's signifying the engine itself. It's gray right now because it's off. And then you can also see the fuel line right there. It doesn't have fuel running to the engine, so it's showing that it's not running. Bottom right is still the same system pressure, cut in, cut out. It's just like in the electric. Down on the bottom, you can see the position of the HOA. That's one of the requirements, again, by NFPA. We have to show the position of the HOA. Marty's playing with it right now. So when you do that, it'll switch from hand to off to automatic or whatever, but it will show the position that it is in on the screen. Next to that, it shows either the automatic or non-automatic. Mentioned automatic is the majority of the panels that we're using. Pressure actuated, meaning it's going to start on a pressure drop. And then the manual shutdown, meaning you have to come in there and manually stop the pump. It's going to run indefinitely until somebody hits the stop button, which can also be done as an automatic shutdown. And then we have the same date, time, and temperature settings up there on the top right. I think one thing that we should show, Marty, you could, if you want to enable the automatic shutdown, because I don't believe we did that on the last one. And then we can show what happens during the automatic shutdown as far as the requirements that need to be met.
Let me get this into automatic here. Hold on.
Switch to auto and then drop the pressure so we can get an automatic start.
Done.
Yeah, right now it's cranking. The engine's cranking. Like I mentioned, you can see right now it's pulling from battery bank 2 and it's trying for 6 more seconds. And it's number 1 of 6. So if it's not successful here, it's going to take a break for 15 seconds, and then it's going to try from battery bank 1. And it will continue to do that 6 times until it eventually fails to start, which is one of the tests that you have to run when you're starting up a diesel. But we can go ahead and give it the on. So now you can see the engine is green and it's running. It was an automatic start and the pump is on demand. So Marty, if you could crank it up, because right now we have the automatic shutdown enabled. So get it above that cutout point. And now you can see we have a 30-minute timer. The pump's going to continue to run for 30 minutes as long as it stays above 120 PSI. After that timer has expired, it will shut itself down. If at any time it drops back down like it just did and then goes back up, it automatically resets the timer. So it's got to see a sustained above 120 PSI for 30 minutes before it will shut down. And that timer is adjustable. You can drop it down to, whatever time you want it to be. But it has to satisfy those conditions for whatever your preset time is before it will stop. Marty, if you want to go ahead, we can stop it now. I think we didn't show a periodic test, like the run test. We didn't do the run test button on the electric.
Sure.
So I think that's a good thing. With the diesel, we do recommend using the run test button, and we can show you why with a set of alarms. But if you push the run test button and then drop you kind of have to play with the
yeah, I got to drop the pressure too because it's a demo.
Yeah.
Hold on.
I think it needs to be an auto. Yep. Well, right now it's showing that it was an automatic start.
Yep, I got that. Let me jump this up. Should kick in.
There we go.
There you go.
Yep. Give the engine run too.
Done.
All right. So now we're doing a run test, and it's going to run for 30 minutes. Of course, the pressure would typically it's going to jump back up above that cutout point because you're running on a closed system, so you don't have to worry about it being below the cut-in point. And it's going to run for 30 minutes and shut itself down, and it's going to log it as a run test versus an auto start. Most people will just open up a valve, drop the pressure, the pump kicks back on because again you're on closed system, so the pressure goes back up immediately, but it logs it as an auto start, which to the control panel, an auto start is a fire. And with the way that these, the system is designed, it's sacrificial equipment, so it's going to run nonstop until it thinks the fire is out or somebody stops it or whatever. So when you're trying to just do a test and you open up a valve and it says automatic, if you get any kind of alarm, it's going to keep running anyway because it's made to keep running to failure. But if you push the run test button and you get, say, high coolant or high raw water, whatever, or low oil pressure, if there's any kind of alarm like that, it will stop itself because it knows it's a test. So it just gives you a little bit of protection when you're doing a test. So Marty showed the engine alarm, and like you can see now, the engine is gray, so it shut itself off. If it was an automatic start, it wouldn't stop. It would have continued to run even with the high temperature. So The run test gives you a little bit of protection when you're doing a test versus just the auto start. Let's see. If you click on the engine itself, just do a click on the motor. This is a shortcut to the event log, so you can see everything that we've done so far. Just anything that, just like in the electric, anything that happens on the control panel, it goes into the event logs. It goes into this. This is the first 500 events, but then, like we showed before, there's the archive spot where the saved logs are. So all of that will go into that as well. And all of these submenus are the same as in the electric. Marty, start it again on an auto start. And then we can give the same alarm that we just did before, your engine alarm, the coolant, or whatever it is, I guess just called an engine alarm there. So you can see it says engine trouble, high temp. This is a critical alarm, but the engine is still running. The only thing that will shut down a diesel is going to be overspeed. See, now we've lost a battery and it's still going.
So again, for people who want to look at what's going on with the complete system, anything that's highlighted in red is off and non-functioning. And it's really easy. You just look at the screen. You don't even have to, you know there's an issue. And look at the bottom of the screen, and it is giving you all the alarms that it is sensing right now. You don't even have to go down, hit the main menu to the bell, and look at all the active alarms you have. Pump on demand, high engine temp, engine trouble, and battery failure, all active right now.
Also, the bell with all of this. The bell would be ringing with all of that going on as well. The critical.
Yes. Well, my demo doesn't have a bell, nor do I want one.
No.
But anyway, the whole point is it scrolls at the bottom, or you just go down and you could read them right there. And again, you can't reset them because they're all active. Now, I could reset one quite easily. I could just bump up the pressure. And all that would do is just eliminate one of those alarms. But we have three that are critical. They're red. So if I correct those a little bit, let's see. Let's do this one. Let's do that one. Both of them are clean.
Yep.
Now, the worst case.
Overspeed. Like I said, that's the only thing that will shut down the diesel. And you can see now it's red. It says overspeed, so it tells you why it stopped. Probably you would have figured that out before, though, because I'd imagine a diesel going into overspeed is quite noisy.
Yeah, I've not really seen an overspeed yet. Hopefully I won't.
No. Let's think. Is there anything else with the diesel that's different from the electric?
Let's see here. Everything else as far as downloading data, I mean, this is why we spent so much time on the electric, because the adjustments for the config, it's the same. The alarms, same. We can test any of these.
Yeah.
We go into events, same thing. Pressure curve, same thing. Save logs, pump curve, statistics, same thing with the download. Same thing with the interval we could set. Jockey pump adjustments if we want the pressure. Typically, if you don't put the jockey pump cut in, cut out, you're probably looking at about 85% or more accuracy, because it's still going to do it. It's still going to monitor it. But if you put it in there, it increases the accuracy tremendously, probably well over 90% or more. I mean, really all you're going to do, it's almost a given when you have pressure drop, and then it veers its way up. And if I were to show this to you real quick, let's go back to this. I'm actually shifting all this over. So if I bounce it up to 5 hours, it'll go, there we go. See if I can show you what I'm trying to do here. 20 minutes. 5, there we go. So again, I drop pressure and the pressure drops below, but it doesn't go all the way to the cut in, and it increases. It's really the jockey pump's doing its job.
Right.
That's really what we're talking about there. So, and it makes it easy. But it's nicer to put it in because you will have the cut in, cut out of a jockey. So why not just input it?
It increases the accuracy, but it'll do it automatically.
Sure. But everything else is the same. I mean, we're talking languages. I'm sure there's things that we could get in. Excuse me. Sure, there's things that we can get in that are a little bit more in depth, but I think that the Q&A, we can take that offline and do individual ones with the live view if necessary.
Right.
The data's here. I mean, this is key right here. The download of the events and the statistics are it's the history of the whole controller since day one. And literally having live pressure curves and power curves that you can watch. You can adjust to see what's been going on. You're not going to see much on a diesel for power, but again, save logs. But having the download capability of right there at the fingertips of downloading all this data, and it's listed in a very chronological order in a spreadsheet, it really makes life easy because this is the first thing we'll ask you is, can you please do a download of the event logs? And we'll analyze all this for you. Or you may be wanting to do it yourself, which is fine. But again, the technology has really made our lives easier. And we're in the process of working on enhancing and upgrading our app. Again, each of these controllers, the operators themselves have Wi-Fi as standard. And we don't do Bluetooth. Wi-Fi is actually better. And so having an app to be able to make some uploads, downloads of the data or upload of software wirelessly while you're in the room working on that device. It's a dedicated unit to be able to access it. It's not like you can get Google or anything from it. It's not like that. It's really proprietary. So it really ties in specifically to the Wi-Fi from this operator itself. So that's in the future. We'll have some presentations on that as it becomes available this year, later in the year. But again, the technology just makes your life easier by just looking at the color that's here. And visually, it will tell you on the front of the screen what the problem is. I don't know if there's anything else that we're missing here.
I think that sums it all up. I mean, we did the majority of it with the electric, and I think that sums up everything on the ViZiTouch.
Sure. Okay, well, I think we're done from here. I'm just going to leave it at that, and appreciate you attending. We're looking forward to all the Q&A.
Absolutely.
Hey, everybody. Hope you enjoyed that presentation. Now let's get on with our Q&A. I saw some really good questions come in while Marty and Cole were presenting. So let's tackle the first one. How long does it take to upload? The YouTube video is accelerated, but how long should we wait before restarting? I think this was sent in at the beginning of the presentation. Richard, if you can clarify, that would be helpful.
That'd be great.
Let's move on to the next one. We'll wait for Richard. If you have a system to operate up to 290 PSI, should you adjust the minimum point on that scale? Should the max reading be 400 PSI?
Yeah, you could do that. It definitely gives you a broader range on the scale, the PSI scale there, so that you wouldn't be maxed out on the scale. So if you wanted to bump up to to 400 psi, it would definitely give you a little bit more range on there.
Yeah, there's no requirement by code or anything. It's really your personal choice.
Next question is, does using the flange-mounted isolating switch to shut off the motor under load potentially damage the switch?
No. I mean, again, okay. You're saying basically under load, potentially damaging the switch. Really what happens is if the only reason you're going to use a flange-mounted operator to shut a motor under load off is probably in an emergency situation. And in that particular case, you know, under load, you're going to open. There's always potential for arcing, more excessive arcing because it is under load. But the reason that you would do that rather than just hitting the stop button probably is a sense of urgency. And been there, done that before. I think the switches are rated for, or actually we're talking flange-mounted operator is an isolated breaker, molded case switch, and a magnetic breaker. So, you know, they have been tested for certain ranges of increased power. Again, the only reason you'd probably do that is because of a sense of urgency or an emergency. So it's really a hard answer saying 100% that it won't damage it, but again, it's the reason that you're doing it. And breakers, you know, open and close all the time in situations where they're under load too.
We received a clarification from Richard. He said, when you have to update the software and insert the USB, the screen goes blank while uploading. How long does this take? Because in our YouTube videos that we filmed, we had to accelerate because it was a little bit too long for visual purposes.
I guess. I think it's still only, you know, maybe 10 seconds. It doesn't take that long. You just have to, it takes a couple seconds for it to recognize that you have the USB in there, and it takes a few seconds to do the download. Then there's another couple seconds. It's gotten to 100% before it, you know, it leaves the screen. But I'd say the total is maybe 10 seconds.
Okay, great. So the next question is, can I download logs by Modbus?
No, not to my knowledge. I mean, Modbus is standard, has been standard with the ViZiTouch for a lot of years. It's Modbus TCP/IP. If you'd like, you can go to our website, and there is a PDF file that actually has all the registers information you can draw from this. Now, maybe I jumped too soon and said no. Without looking at the specific registers and information you can draw from that through Modbus, using that TCP/IP connection, you know, there might be a lot of data that is similar to what you're talking about in a sense, but to you know, download like we talk about on a USB, you know, is probably a little bit more in depth. But I would suggest, obviously, to download that PDF with all the Modbus registers, take a look at the information that each register allows you to pull, and see if that answers your question as to exactly what you're looking for. And if you have a question beyond that, you know, reach out to Cole or myself, and we'll help as much as possible. So.
Just to add to that, Marty, just to let people know, that document you're looking for is in the Tech Center under Technical Bulletin and Documents on our website.
Perfect.
So now the next question is, how long will the jockey pump run before the main pump is commanded on? At that time, does the jockey continue or run? Does it shut off?
That's going to depend on the system and the pressure set points and all of that. There's not going to be a single answer to that. The main pump is going to come on if the jockey pump can't keep up the pressure. Because the whole point of the jockey is to maintain pressure in the system. So if there's a huge leak or a fire, the jockey's not going to be able to handle that kind of load. So that's when the fire pump is going to come on. And then as far as how long it runs, I mean, again, that depends on the settings for each system.
So to add to that, and that's answered quite well, is that jockey pump, as Cole mentioned, it will shut off only when it reaches, the system pressure reaches that cutout or turn off point of the jockey pump setting itself, which will vary from system to system. So if you do reach it, you know, the main controller kicks on, and it automatically pushes the system pressure up beyond that turn-off point that the jockey set for, the jockey will automatically shut off. The main controller typically would have to be manually shut down, but.
Okay, great. Just to remind everyone, be sure to send in your questions. We're gonna answer as many as we can today. And if by any chance we do not get to your question, we will send you an email with the response.
Sure.
So let's get to the next one. If there's a fire while the fire pump is running, its weekly test, what is the fire pump controller going to do? What are you going to see at the fire alarm panel?
For that, it would show most likely an automatic start. I mean, if you're doing the run test, you're doing it, you're going to be bumped up on a closed system. The pressure is going to go up above that cutout point immediately because there's no heads open. But if there's a fire, the heads are open, the pressure is going to be lower, the pump's going to be running. And if there's a fire during the test and the pressure drops back down, it's going to call it an automatic start. So it'll just switch over from a run test to an automatic start. And it's going to run. You're not without fire protection when you're doing a test. So it's always still monitoring the pressure in the system. So if it drops down, it'll continue to run. And it'll just make that transition from run test to auto.
To add to this, since it is, we're in life safety business, exactly what Cole said, the two things that you'll see is that when that system pressure drops below the cut-in, you'll see two things. The box to the right of the motor will say auto, and the pump on demand yellow alarm at the bottom of the screen will pop up and flash pump on demand and auto, and that's what you'll see.
Great. So the next question we have is, how do you reset the transducer?
It's a good question. So we want to basically reset or recalibrate. This is one I think that Cole or myself or both of us should do offline. We can actually do this on a Teams session with our live view and kind of show you. It's very, very easy. And without having it in front of us again, it's a lot easier to show you a picture. It's worth 1,000 words. It doesn't take much to recalibrate a pressure transducer.
Also on our YouTube page, there is some instructional videos on how to calibrate a transducer for the GPX and GPD. So that also may be helpful, but it would be best to get in touch with Marty or Cole, and they can explain a little bit further.
Yeah, I'd like to make a couple comments before we look at any other questions, just to point this out. And this, from what our control presentation, the last session that we had, it was brought to my attention by one of our customers. So I want to make this aware to everyone, is that our controller has a routine self-check of the pressure transducer. We don't advertise it. We don't market it. It's not even that I remember seeing it in our literature. But what we have done is we have, again, a self-check routine that we follow every 7 days to check that pressure transducer's activity. Now, let's clarify this. If you do a self-test using anytime you operate that solenoid, which again could be the manual run test, which activates that solenoid, you will reset that 7-day period. If you have a pump on demand where you have a system pressure drop, it doesn't reset anything. But again, if you're manually doing something that activates that test solenoid, it will reset it from day one again. You'll have 7 days, and it will do a self-check. And when that self-test and check is done, it will actually log itself in the event log as a self-check or self-test for the PT. Just want to make sure you're aware of that, because on the logs, you might look at the logs and go, oh my goodness, well, this shows that we have something going on. It does not turn the system on. It's an internal self-check. But this is really good because, when it's not active and we're not using that button and actually doing any testing, rest assured that every week, typically, it would do a self-test itself. Number two is I wanted to bring up the situation with the second technical notice that was just recently sent out. During COVID, we've had a lot of delays, and there are some jobs that are big that maybe actually will cause a situation for, instead of a startup within 6 to 12 months, it might be 18 to 24. But again, the pandemic has caused delays on commissioning of controllers. When we ship our controller, we put a typical charge on the internal battery, which is what we're talking about. That's that little battery marker on the top right corner of the ViZiTouch I pointed out during the presentation. And you'll see if it's a quarter, half, 3/4 full, whatever. But we require at least 25% or a quarter charge to actively operate this. We do put a charge, sufficient charge from the factory in for that battery. But you know, the nature of batteries is to naturally discharge over a period of time when it's not in a charge mode. And I just want to reaffirm that second technical memo that went out. I think Sebastian sent it out a couple days ago. Actually, it was forwarded out by marketing and Melissa's group. It's a software fix. So there's a download that would take place. I would say download it on a few USBs, a dedicated USB. There's nothing else but that software download into that USB. Have a couple, one for each tech. And before you even energize that controller, insert that USB into the front mounted USB port, energize it, and follow that procedure. That software will update, and it solves the issue and concern that we've had in the past that some of you have encountered with I'll say undercharged batteries because normal degradation over time and discharge. So if you have questions on that, reach out to myself or Cole. But again, that solution, which is software driven, was sent out this week by marketing. So I wanted to bring that to everyone's attention since I have everyone captive here. So.
Well, we do not have any more questions coming in, but I want to take this opportunity to let everyone know that this presentation will be available on demand. If you are registered, you will automatically get an email as soon as it's available. So that's a common question that I get on a regular basis. All our webinars are available on demand within approximately a week at the most. So if you miss something, you want to rewind, go ahead, you will have access.
So please, I have to make two comments. We're not paid actors. We're human. We do make errors. And I look forward to feedback from any of you, to Cole or myself or Melissa. If there's a product or a topic that you would like to see a presentation done on, please let us know. I mean, we have a feel of what we'd like to cover, but that doesn't mean it's what you want to see. You know, and that's important. So please give us feedback. And I'm sure between all of us, we can put a nice program, you know, whether it be a half hour, 45 minutes, hour, you know, whatever is required on that particular topic you'd like us to talk about. So appreciate all that.
Yeah, and Marty, to add to that, I completely agree with you. We really want to hear from you guys to hear what you want to hear about. And you can do so also. We would appreciate that you fill out the survey that will pop up after this webinar has ended. And there's a comment section where you can leave a comment and send us your suggestions. We read through all of them to make sure that you're satisfied with our presentation, and any other helpful hints would be appreciated.
Sure. Oh, you let us off easy. Are we done with all the questions?
I think so.
Looks like it's it.
Or maybe we've done too many presentations around the US, Cole.
Everybody knows everything.
Well, look out, everyone, for February. We will be back, and we will be doing another webinar on another topic. We haven't decided yet. So if you send us your feedback, maybe it'll be something you requested. So thank you, Marty. Thank you, Cole. That was a great presentation, and we can't wait to see you at the next one. Take care, everybody.
Thank you, Melissa. Thank you, Cole. Thank you, everyone. We'll see you later.
Thank you.